Thales Alenia Space, a joint venture between Thales 67% and Leonardo 33%, has been selected by OHB, prime contractor, and the European Space Agency ESA, to provide the communications system as well as the power conditioning and distribution unit for the HERA mission. Named after the Greek goddess of marriage, HERA, European contribution to AIDA international cooperation, aims to find out capability of deflecting an asteroid and prevent it from hitting Earth. AIDA consists of two missions: NASA's Double Asteroid Redirection Test, a kinetic impactor designed to deviate the orbit of the smaller of the two Didymos asteroids, and ESA's HERA Inspector spacecraft, that will rendezvous the Didymos target asteroid about 4 years after the DART impact. HERA, scheduled for launch in 2024, will travel for the first time in history to explore a binary asteroid system. The systems provided by Thales Alenia Space will be key to the mission, allowing controlling and tracking the spacecraft from a distance up to 500 million km far away, to send all the information gathered by HERA back to Earth and to perform radio science. Thales Alenia Space in Spain will be responsible for the X-band communications system, leading an industrial consortium which includes Thales Alenia Space in Italy, responsible for the state-of-art deep space transponder that, exploiting a flight-proven digital platform, will allow robust communication with the ground station, and Thales Alenia Space in Belgium, responsible for the traveling wave tube amplifiers, among other companies. Thales Alenia Space in Belgium will also provide the PCDU, the electrical core of the spacecraft. HERA will send key information to Earth on the physical properties of dimorphos, including mass, size, shape, volume, density, porosity, size, distribution of surface material to determine the momentum transfer efficiency of the impact and to allow scaling it to different asteroids. Details of the crater formed by the impact to improve our understanding of the cratering process, and observations on the subtle dynamic effects that are difficult to detect from ground-based observations. Asteroids are bodies originated in the young stars' nebulae that never grew to planets, formed of rock and metal. Among them, those that have an orbit that brings them close to Earth, known as near-Earth asteroids, pose a risk of hitting the Earth. Neither the smaller near-Earth asteroids nor the larger ones pose a real threat to humanity. Small asteroids actually hit the Earth quite frequently with no consequences. The larger ones, although potentially dangerous, are well known and tracked, and it takes millions of years to have one of them hitting the Earth. It is the mid-sized class asteroids of more than 100 meters the ones we need to worry about, such as the asteroid HERA will explore. There are about 30,000 near-Earth asteroids of the 100 to 300 meter size class, 82% of them still to be spotted, hitting the Earth every 10,000 years. The impact energy of such an asteroid is equivalent to around 50 megatons of TNT, the power of a Tsar bomber. The effect of such an impact would be devastating if it reached a populated area, capable to destroy an entire city or to create a tsunami if it impacted a sea. The Didymos binary asteroid system is prototypical of the thousands of asteroids that pose a hazardous risk of impact to our planet. Around the main body, 780 meter in diameter orbits a 160 meter moonlet, dimorphos, similar in size to the Great Pyramid of Giza. HERA will target this moonlet, which will become the smallest asteroid ever visited by a probe. The DART spacecraft will be launched in July 2021 and is expected to hit the surface of Dimorphos on September 2022 at a speed of almost 7 km per second, which is expected to modify its orbit around Didymos and create a substantial crater. Dimorphos will thus become the first object in the solar system whose orbit and physical characteristics have been measurably modified by human effort.